Hi guys. All right, we're still looking at things we should know for pre-calculus but may have forgotten. Today we're looking at some more function rules and some review of transformations. So the first function rule we want to look at is compositions. So let's suppose that f of x is 2x and g of x is 3x squared plus 1. We want to find f composition g of 4. You will find that I always rewrite this as f of g of 4 because that tells me I work inside out. The 4 gets plugged into g first and then that answer gets plugged into f. So the first thing I'm going to do is I'm going to find g of 4. So my g function, everywhere there's an x, I'm going to put the 4. So 3 times 4 squared plus 1. 4 squared is 16. 3 times 16 is 48, plus 1 is 49. So now I'm going to take this and I'm going to find f of 49. So now what we're going to do is in f, every place there's an x, we're going to put that 49. So it's 2 times, and we're going to put that 49 in there. And 2 times 49 gives us 98. And there we go. We found the value of f composition g of 4. All right, now let's look at f composition f of 1. So we're going to find f of 1. So the first thing we're going to do is we're going to put 1 into f. So we're going to find f of 1. So the rule for f is 2 times something, and we are putting the 1 in for the x. Well, 2 times 1 is 2. Now we're going to take this, and we're going to put this up here, and we're going to find f of 2, because we just found that f of 1 is 2. Now f of 2, again, the rule for f is 2 times something, and our something is 2. And 2 times 2 is 4. So f composition f of 1 is 4. Now I want to pause here and show you how you can do this on the TI-Nspire. So grab your calculators, and here we go. Okay, so here we are in a calculator. We're going to do menu. We're going to put in a graph page. Now we're going to put in our two functions. We're going to put f of x in f1. So f of x is 2x, and then I'm going to arrow down. And in f2, I'm going to put g of x, which is 3x squared plus 1. Now you might find it helpful to write on your paper that f of x is now f1 of x, and g of x is now f2 of x, because the calculator has new names for them. And now we're going to add a page. And we're going to add a calculator page. Now I asked you to do f of g of 4 in A. F of g of 4. So we're going to tell the calculator to do the same thing. Only the calculator called f f1 of. Now instead of g, the calculator called it f2 of. And I asked you to evaluate that at 4. Hit enter. There's that answer 98 that we got before. In B, we wanted to do f composition f of 1, so f of 1. Now f, we put in f1, so it's f1 of f. Again, f is in f1 of 1. Hit enter. There's the answer 4 that we got by hand. Okay, so there you go. Great for checking purposes. Back to our notes. Okay. Now let's come back and do g composition f of x. So again, I'm going to rewrite this. G of f of x. Now here's the catch. It's hard to plug x into f. We already did that. So yes, you can look at this as g of 2x. That's one way to look at this. I also sometimes look at this as, okay, the rule for g is 3 times something squared plus 1. Well, what's my something? In this case, my something is f of x, which is 2x. So we're going to say our rule for g is 3 times something squared plus 1 and my something, f of x, is 2x. Now I still have to do the arithmetic that goes along with this, or the algebra. 3 times 2x being squared is 4x squared, plus 1. Now we multiply by 3, so that's 12x squared plus 1, and now we have our answer. There we go. Let's try another one. Now we want to do g of x. So this time our outside function is still g of x, which is 3 times something squared plus 1. Only this time the inside is the function g of x. So we're putting 3x squared plus 1 in there. Now please be very careful. When you square 3x squared plus 1, you have to do 3x squared plus 1 times 3x squared plus 1. Do not just square the first part and square the second part. So let's do some algebra here. We're going to keep the 3, and when we do this multiplication, 3x squared times 3x squared is 9x to the 4th. We're going to get a 3x squared here and another 3x squared here. So that's 6x squareds. And then 1 times 1 is 1. And don't forget this plus 1 hanging out over here. Now we're going to distribute the 3. So 3 times 9, that's going to be 27x to the 4th. 3 times 6, that's 18x squared. Plus 3 times 1 is 3. And we still have this plus 1 hanging out. Now we combine like terms. 27x to the 4th plus 18x squared plus 4. And unless you simplify, you will not receive full credit. So please remember to do that. Okay, awesome. All right, let's look at the next function rule. Inverses. Okay, so remember, inverses are opposite functions. They undo each other. And there's more than one way to find the inverse of a function. Let's look at the Algebra 2 way, the method that you were taught. In Algebra 2, first thing is you had to change the f of x to y. And in Algebra 2, you learned that to find an inverse, you switch x and y. So to find the inverse, your y becomes x equals negative 3. Your x becomes y plus 2. And now you solve for y. So, okay, we're going to subtract the 2 from both sides. And then we have to divide by negative 3. So we have y equals negative x minus 2 over negative 3, which is the same as y equals, why do I have a negative x? Sorry about that. Don't know where that came from. So y equals negative x over 3 or negative 1/3 x, whichever you want, plus 2/3. That's an okay way to write this. However, if the name of the function was f of x, you cannot give your answer as y equals. Okay, and you cannot use y inverse. The name of the function is f raised to the negative 1. That's how you write it, but it's read f inverse of x equals negative 1/3 x plus 2/3. And this would be your final answer. Now, if you had left it over here, your f inverse of x would be x minus 2 over negative 3. And technically, this answer is fine. There's nothing wrong with that answer. Okay, both of those are correct. So if I give you this answer, you want to check and see if your answer is equivalent. Okay, now there is another way to do this. And I will be honest, this math 4 method doesn't work for some of the more complicated problems. But it's nice to know if you have some of the easy ones, it's very quick to do. The math 4 method, remember, inverses are opposite functions. They undo each other. So what we do are the opposite operations in the opposite order. So for instance, if we have f of x equals negative 3x plus 2. If we were going to find, let's say, f of 10, we would plug the negative 10 in here. The first thing we would do is multiply by negative 3, and then we would add 2, correct? Okay, so that's easy enough. So now when we want to find the inverse, we start f inverse of x, we write our x, and we do the opposite operations in the opposite order. What's the opposite of adding 2? Well, that's subtracting 2. What's the opposite of multiplying by negative 3? That's dividing by negative 3. And lo and behold, same answer, a lot less algebra. But remember, when we solve this equation, solving for y, we are doing those opposite operations in the opposite order. We subtracted 2, then we divided by negative 3. That's why it works. Another thing to remember is that you can graph a function and its inverse, and they should be reflections over that line y equals f. Y equals x. If they are not reflections over that line, something's incorrect. You made a mistake somewhere, so watch out for that. Now, f of x equals the quantity x minus 4 squared. Okay, so this function is a parabola that has been shifted over 4. And shifted to the right 4. So this is a function. Oh, that's a crazy looking parabola. Just trust me, it's a parabola. Okay, so it's a parabola that's been shifted over 4. It is a function. However, it's not a one-to-one function. What does that mean? Well, a function said that the x values are used only once. The fact that it's one-to-one means the y values are used only once. Now, if I was to draw a horizontal line where all the y values are the same, it hits this graph twice, which means that those particular y values are used twice. Now, when I find the inverse, those y values become the x values. And now the x values in the inverse are used more than once, and that means the inverse is not a function. However, if we are asked to find f inverse of x, that is a function notation, which means we have to have a function. All right, that's the inverse function. So in order to do that, we need to restrict the domain. So we have a choice. We can either use the left-hand side of the parabola or the right-hand side of the parabola, and it's totally up to you. Or whatever I tell you on the test to do. I'm going to use the right-hand side where the x's are greater than or equal to 4. So we're only going to use this piece of the function. Okay, so we're restricting it. Now we can do those little tricks we learned, right? If we were to plug in 10, say for x, first thing we would do is subtract 2, and then we would square it. And I'm doing the 4R method. So f inverse, 4H method, f inverse of x, and I start with x. Opposite operations in the opposite order. The opposite of squaring is square rooting. The opposite of subtracting 4 is adding 4. Okay? And the only other thing that you might want to do here is say, oh, wait a minute, I have a radical. My x's have to be greater than or equal to 0. Look at this. Now we would have a function. Okay? Because what happens is when you take this piece of the parabola and you reflect it over the line y equals x, we now have this. So here's f of x, here's f inverse of x, this is at 4, now the y value is at 4. Okay? Good. Let's take a look at this one. Here we go. G of x is the function x minus 1 over x plus 3. This is not one you want to do with the new math form method. First thing we do is we change the g of x to y. So we know, first thing we do is we switch x and y. So to find the inverse, we switch the x and y. So it's x equals y minus 1 over y plus 3. Now the next thing we're going to do is we're going to solve for y. Now there's a few steps with that. We're going to cross multiply, and I hate that term cross multiply. I always say it's a figment of a middle school teacher's imagination. There is no function cross multiply. I'm going to put the x over 1. We're multiplying both sides of the equation by the denominator y plus 3. So that's going to give us x times y is xy, x times 3 is 3x, and 1 times y minus 1 is y minus 1. The next step is bring everything with a y to one side and everything else to the other side of the equation. So we need to bring the y to the left and the 3x to the right. So I'm going to subtract y from both sides, and I'm going to subtract 3x from both sides. So this will give me xy minus y equals negative 3x minus 1. Now, this step isn't always necessary. Sometimes it is. Factor out the common y if necessary. In our case, it is necessary. We're trying to get y by itself, but there's 2 and we can't really subtract them. So we factor out the y. That'll leave us with x minus 1 equals negative 3x minus 1. Okay, now we divide. By the other factor. So to get the y by itself, we divide by x minus 1. So we have y equals negative 3x minus 1 over x minus 1. The only step left is to rename it if necessary. So if the original function was named y, you'd be done. But our original function was named g of x, which means our inverse is g inverse of x is negative 3x minus 1 over x minus 1. Phew, that was fun, wasn't it? I know it wasn't. It'll get better. It's tedious algebra on those, right? Tedious algebra. Okay. Transformations review. Let's review a little bit on transformations. All right, so first, if we have y equals a number a times the function f evaluated at x minus h plus k outside the function, a represents a vertical stretch or compression, which will make the graph look thinner or wider. All right, but it's really being stretched or compressed in the vertical direction. The next thing, h, which is inside the function, that's a horizontal translation. It's going to move the graph left or right. Now, when it's inside, it does opposite of what you think it's going to do. If it's a x plus h, it moves left. If it's x minus h, it moves to the right. Okay, Then we have the K. The K is the vertical translation. That's moving the graph up or down. And up, that's when you're adding K outside the function. Down is when you're subtracting K outside the function. All right, next comes y equals negative f of x. Y equals negative f of x. That is a reflection over the x-axis. What it's really doing is it's negating the y values. And if you look at it, it's exactly what it says. It says negative f of x. This is a y value, so it's negating the y's. Then we have one more here, y equals f of negative x. Notice what it's saying, negative x. It's telling you to negate the x values. Well, what transformation tells you to negate the x values? That's a reflection over the y-axis. Okay. So let's describe these transformations. So if we have f of x plus 1, that's going up 1. And I'm okay if you just do arrow up 1. That's fine with me. F of x plus 1, if you're adding inside, that's going to move to the left one. The negative in front of the f of x, that's a reflection over the x-axis. Subtracting inside, that moves to the right 2. Subtracting 2 outside, that goes down 2. Negative x inside, that's the reflection over the y-axis. And now we have two things going on. The negative 1 inside tells me we're going to move to the right one, but the plus 3 outside tells me I'm going to go up 3. Okay? Good. Now, and then here I just have some visuals for you to show you the vertical stretch or compression, okay? That when you have a number that's bigger than 1, it's stretched vertically, like pulling a marshmallow and it stretches, it gets thinner. When it's a fraction that's between 0 and 1, that's like when you squish the marshmallow, it gets lower, but it also gets wider, okay? And that's why the red graph looks the way it does. And then this is the new one, the horizontal stretch or compression, okay? So you can see again that when the constant is a number bigger than 1, the graph gets skinnier. When the constant is a fraction between 0 and 1, the function got wider, but it was pulled wider this time. All right, guys, I'll see you in class. Good luck.